Hey guys, it's Ferdinand Dandy once again, the guy behind the DR100 Watt Concept project. It's a Class D power amplifier, and in this video, it's me and my son doing our hobby stuff at Starbucks. It's a kind of father and son bonding plus our hobby. As you can see, I'm studying a PC-based oscilloscope while my son is playing his video game, his favorite one on the iPad, with a matching latte coffee for me, and for him is a chocolate. So what is this PC-based oscilloscope? It's a Loto instrument PC-based oscilloscope specific to the model OSC482H. H is very important. It's a 2-channel 20 megahertz 50 mega sampling rate, which is I believe is a good for audio power amplifier measurement, which is within the audio bandwidth of 20 hertz to 20 kilohertz. So this video is just a starter to understand about the OSC482 with the intention that in the future, once I able to understand it and can study it, I can use that in my DIY power amplifier, especially for my Class D power amplifier. So the study will gonna be in terms of easy to use, a friendly user, precision with an automatic measurement, data logging or that kind of data gathering plus saving, in package an add-on signal generator with a sine wave, square wave, or the triangular wave. There is also a function of frequency response, and when we use with an add-on module, a differential input module, it can perfectly measure the BTL or the bipolar tie load output of a Class D power amplifier. You know, the BTL is not reference to ground, so it should be measured by a differential input or differential probe. So the model that I have in here from Loto Instrument is the OSC482H. The preliminary hardware setting will gonna be to select in here between a USB and UART, and I selected that to be in the USB because I'm going to make use of the USB to power it on and also for the connection. You can see also in here there is a switch in here where you can push it. If this is shorter, then this is in the power on mode, and then press it on again, it is longer, and this is in the power off stage. That means to say it's on the standby mode. So there is also an LED in here, and we're going to see that after I connect the B-type USB on the USB slot to the one right now in here. It is connected, and then connect the other end of the USB to the PC. Let me put that one in there. That's it. That is the A-type USB, and then power it on. You can hear the ding dong from the PC. This means to say that this hardware is detected, and then you can see the 2 LEDs in here. This is for the power, the red one, and the green one is means to say that the connection between this hardware and the PC is successful. That is basically the preliminary setup for this hardware. Now I'm going to put in here for a better demonstration. There you go, there you go, there you go, there you go. Now the OSC482 comes with an add-on module. This one in here, this is a signal generator, or what we call it as an audio generator, to be specific for use in audio. And the model number is S02V8. S02 should be version 8, and we have 2 BNC in here. This is the output, and this is the channel B input. We're going to take a look at this why there is a channel B input in here when we come to that function. But for now, this is just the module for the signal generator, and there are two knobs in here, one for the amplitude and the other one is for the offset. So this is basically responsible for generating the audio frequency, sine wave, square wave, and also for a triangular wave. I'm going to add on and connect it into the OSC482 oscilloscope. The LED is on. As I told you that this is the output of the audio generator, and then put it into the channel A. So this one in here is the channel A and this one is the channel B, and you can see that channel B is actually blocked by the module, but you can actually input the channel B in here. That is the main purpose why I mentioned earlier there is an input for the channel B. When I get this oscilloscope, I don't get the software, but I can find that one using my browser. So in my computer, I type in Loto instrument, then I can search and I can find the software download, and then I navigate using the mouse and find the download link. What I found is that, which is quite strange, I found it out that the download link is in the Google Drive, wherein if you are inside China, Google is basically censored. That's the reality. That's the reality. Well, that's a little bit headache actually, but long story short, I able to find the application software, the OSC482XX, and you don't have actually to install it, I just have to uncompress it and run the exe file. I'll put it in my desktop so I can easily find it, and there you go, I can run the application software now for the Loto instrument OSC482H. Connect the PC to the OSC482H. Let's do some setup. Let me just choose the option to normal. Here it is. There is a selection in here. There is a normal, peak, and high resolution, but I'd like to have it for normal right now. I just use the default setting when I just run the software, and then the waveform refresh rate is just like just setting to about 6, and then click the start device, and then you can see that the channel A, which is in blue color, and the channel B, which is in yellow color, is already available in here, means to say they are displaying on the screen. The first thing to do is to find the channel A. That is point the mouse, then left click it, and then choose the reset A0 voltage baseline. And the main reason for this is that I'd like that the channel A will be set it into the baseline, which is 0. Then do the same with the channel B. Now you can see that both the channel A and the channel B signal is now at 0 baseline. This is something that I need to do first before I'm going to start any significant measurement or any meaningful measurement. In my demonstration setup, I'm using the channel A, so the output of the audio signal generator will input into the channel A. So I'm going to focus on the channel A and I'm going to turn off channel B. So channel A now is enabled and the color is blue. If I'm going to just for demonstration's sake, if I'm going to turn it off, I just have to click this and then the color will become light dark, which means to say that it's turned off. So I'm going to turn it on and the color again is blue. And then for the AC and DC, I'm going to make use of AC because I'm measuring AC signal. For the time division, I just leave it there, whatever is the setting right now. Later on, I will do some automatic setup, which means to say that it will go to choose the best setting for the time division as well as the amplitude. Let it just that setting right now. Alright, it's time to set up the audio generator. Let me find in the menu, there is what we call the EXT. I don't know what is EXT means. Probably it's called extended or extension or whatever. Frankly speaking, I don't know. So to start with, I'm going to press the button with the name signal generator, and then I'm going to select sine wave, and I set the frequency to 1000 hertz, or that is 1 kilohertz. And then I'm going to click the red off button, which is in the off state right now, turning it on into a green color, which is meaning that the audio signal generator is in the active mode or outputting the required signal. I think I'm missing something, which probably the question right now is where to adjust the amplitude of the sine wave at 1 kilohertz. You have to adjust it in here. There is a knob in here at the signal generator module, wherein you can increase it counterclockwise. Yes, counterclockwise. Simply counterclockwise increase the amplitude, clockwise will decrease the amplitude. That's how you're going to adjust the amplitude of the signal. So now everything is set up, the oscilloscope part and the audio signal generator part. It's done, completely set up. And now it's a time to test this setup by outputting the sine wave. And I can easily do that by pressing the automatic function by selecting automatically the time base, the best time base, and also the base amplitude. And there you go. It's like magic. You got a nice display on the OSC482 right now. That is the sine wave 1 kilohertz. It's good. It's like magic, really. It's like magic. That was successful. So what's now and what's next? That's going to be a measurement demonstration, like measuring the RMS, the peak to peak, the frequency, the minimum, maximum, the pulse, and so on and so forth. We will also see the measurement magnifier. We will also see the measurement in terms of cursor, the FFT, saving, and so on and so forth. And as I'm saying that, this gonna be on the next video, so don't miss that video, guys. Well guys, I have to say goodbye for now, and don't forget to watch the next video, which is gonna be the measurement capability of the OSC482 PC-based oscilloscope. Don't forget to subscribe, by the way, and also the thumbs up. Bye for now, and whatever you do, have a good day.